Yeah, hello everyone. This is Sanjay welcoming you on behalf of Edureka for this Hadoop webinar on distributed cache. So how are you guys doing? So to start with, uh, I'll briefly introduce myself. So my name is Sanjay, and I have 15 in the technology side, and involved in the field of data for around 5 years. So, been part of Hadoop implementations and working on data science and Spark. Okay, so in today's webinar, we'll be talking about essentially about Hadoop and what we have to offer on Hadoop, and also we'll look at one of the key things that we do in Hadoop. Basically, we'll show you a demo on distributed cache. So we'll come to that basically. So just to kind of give you some idea, distributed cache is a facility provided by the MapReduce framework to cache files needed by applications. So we'll come back to that. And before that, we'll talk about Hadoop and a lot of other things. What does the Hadoop framework comprise of, and so on. And uh, so anyone who has a background in Hadoop or has been working, so that I know and I can pace my presentation accordingly. And if you guys can just in one-liner tell me about your background in terms of the technology stack, that will help me, so that this presentation is more relevant to you guys. So I'm looking at a wide variety of uh, responses. So the thing is, what I'm seeing is a lot of you are kind of curious to know about Hadoop and explore the options, what options there are, and want to know about big data and where does data science fit into the scheme of things, or how is it related. So some of you are from Java background and Spring, Hibernate. So that's good, guys. Thanks. So and then we have one or two who have actually who are working on Hadoop or who have done some training. So that's fine too. But by and large, this audience is kind of new to Hadoop or want to know in the context of big data what this is about. Okay. So as I can see, quite a few have this Java background, and even if you don't have, that's not a cause for worry. So, see, Hadoop is a distributed framework for big data, and before that, uh, let me kind of talk about. Yeah, sure, Abhijit, but we have a wider audience to kind of address. Okay. Um, to start with, let's talk about what. Hi, Abhishek. Uh, See, big data is basically a problem statement. Okay, and we are trying to figure out what is the way out, or what is the solution to the big data problem statement. So, uh, when we talk about big data solution, it has to address primarily two things. One is in terms of the storage needs, because by definition, when we talk about big data, it is about the volume of data, it's the wide variety of data, is the velocity or the speed at which it is being generated, and then there are several other characteristics of big data. So I'm sure you guys are well aware, and some of you have that background, so I'll not go into that. Okay. Uh, so some more joinees, some more participants. So hi guys. So just kind of acknowledging your greeting. Uh, so see what we so I was talking about the big data solution. So big data solution has to address two aspects. One is in terms of storage. Okay, so Hadoop provides a very good mechanism, or it provides basically a way to store data in a very I would say, regardless of the kind of data that you have or format, so to say. So it offers almost unlimited data at a virtually very low cost. So it's a very effective medium for storage of big data, and that is a big reason for its popularity. Okay, so that's one of the key things which has driven the adoption of Hadoop. And the other part is processing. So when we talk about processing, we are essentially talking about how do you run the computation with the data that you have. So that can be in terms of your analytics or any kind of processing. It could be batch, it could be real time. See, when Hadoop started almost 7-8 years ago in production, way back in 2007, when Yahoo implemented it, it was a batch only application processing engine, or you could do only batch. But now you have all kinds of different types of applications which you can run on top of Hadoop. So it's come a long way, and it has evolved from the early days, I would like to say. Okay, so so these are the two things that the Hadoop framework tries to address. So storage, for storage we have something called HDFS, or Hadoop Distributed File System. So that HDFS is a fault-tolerant kind of file system, wherein you could have you could partition your data and do replication and all that. Okay, so I see like a few of you are already aware, and since you're working on Hadoop, but just to kind of give the other folks who are not from the Hadoop background some insights. So HDFS takes care of the storage, and on the processing side you have different ways in which you can do your processing. So you could use your Java API. So Java is the language of choice, and other than that you have Pig and Hive as well. So we have this course on Hadoop which is pretty exhaustive, and will walk you through the complete life cycle of how you kind of develop a Hadoop application, or any application which can be a big data solution. So let me open that before I go to this distributed cache. So it's a pretty exhaustive course, as I said. So here we are talking about like what is big data, and in the context of big data, where does Hadoop fit into the scheme of things? And then we'll talk about Hadoop architecture and HDFS. So I briefly mentioned about HDFS. When we say architecture, the way it has evolved. So when Hadoop started, it was a little different from how it is now. But we'll kind of give you a historical background and perspective on how things have evolved and got better. And you have a cluster which you can set up, or you can use when you enroll for this course. You'll get a VM, basically, that so you can get up to speed very quickly without having to go through the nitty-gritties of installing. Even if you want to install, we have the installation guides and everything, the support team and all. So that should be relatively simple. And when we talk about Hadoop, we talk about the processing. So this addresses the storage part of Hadoop, basically HDFS. How do you store big data within the framework? And then the second part is how do you process. So MapReduce is the preferred way of, or it's MapReduce is the engine through which you do the computation or process your data. And they will talk about MapReduce also in a short while from now. Okay. So this is just to kind of give you an overview, and we take a deep dive into MapReduce framework. So there are a couple of modules. In fact, more than that, we have an advanced MapReduce also. So as part of that, we talk about advanced MapReduce concepts, and so one of them we'll be talking about today, which is distributed cache, and I'll be giving a demo on that basically. And then we talk about the other components of the Hadoop ecosystem. So if you want to do some ETL kind of stuff, you can use pig, which is a fairly simple language in terms of semantics. So there are no complications. You don't need Java background and all. So there are enterprises who don't use Java that much when they work on Hadoop. It again depends on the nature of work and what kind of applications that you have. And then for folks from the database background, you have Hive. So we will be learning about Hive and the way we use Hive to query the files or the data that we have. And it's structured very similar to your SQL. So that's your data warehouse on Hadoop. And in the next module, we'll be going through advanced Hive concepts. You create your own custom UDFs and all that. How do you do dynamic partitioning and so on. And then we move on to the Hbase. Hbase is your NoSQL database which runs on top of Hadoop. So it's tightly integrated with Hadoop. So we'll learn about the concepts of NoSQL databases, why they came into being, and what is their USP, and then in particular about Hbase. And when then we do some CRUD operations using Hbase. Okay. So when I say CRUD, it's basically your read write. So it's create, read, update, and delete. And we look at advanced Hbase concepts also. And so that's what I was saying. Your course is pretty exhaustive and will touch upon all the important areas which need to be covered. Yes, Jahar. This is the curriculum of Hadoop developer course, and then we have Uzi, and then you end up with doing a project. So in this module, you will be we'll also be covering Flume as well, which is another component. So it's a pretty hands-on kind of course. So your classes run up to 30 hours, and then you have assignments at the end of each module. And the project also is roughly of 20 hours. So feel free to kind of post your questions. I'll be more than glad to address them. Okay. So it could be on any thing related to Hadoop, and we'll surely try to get around that. All right. So I'll move to the presentation that we have for today. And again, just before that, I would like to highlight one more thing. So as part of this Hadoop training program that we have, we also offer kind of for folks who are new to Java or kind of don't have the expertise in Java, some kind of material is there, and you can go through those assignments, and that will bring you guys up to speed in Java as well. Okay. So let's see what we have for today. So as I said, this is an part of the advanced concepts of MapReduce, that advanced MapReduce module. So let's see what we have. So before that, we'll talk about like the use cases where MapReduce is being used, and again we'll talk about how MapReduce as a paradigm is different from your traditional ways of processing. We'll talk about some of the stuff related to Hadoop 2.x. So Hadoop's current version is 2.7, and you have these releases, major as well as minor, which come out very regularly. So Jar has a question: how important is to learn MapReduce and Java for Hadoop developer? Can one go without getting into depth of MapReduce and Java? Yes, it all depends, as I said, Jar, depends on the kind of application that you are going to work on. So lot of times I've seen in enterprises they don't use much of Java, whereas in product companies and all, they definitely use a lot of Java. So it all depends. So you can get by learning Pig and Hive. So when you code in Pig and Hive, which is very simple, very English-like, especially in Pig, the semantics are very straightforward. So in the background, it kind of runs a MapReduce job. So you don't do the MapReduce coding, but that's what happens behind the scenes. So yes, to answer your question, you can get without actually working in Java on Hadoop. Okay. All right, no problem. So I was talking about the agenda or the objectives for today's session. Again, we'll be talking a little bit about Hadoop 2.0, and then about YARN, which is again has kind of evolved from the early days of Hadoop. So we'll see what YARN brings to the table. And then we'll talk about a little bit in detail about distributed cache, and we'll run a simple MapReduce program with distributed cache. Okay. So Jaideep is asking, so Jaideep, YARN stands for yet another resource negotiator. So I'll talk about that in a short while. Okay. So, so the use cases of MapReduce. So even before that, let me talk a little bit about what MapReduce is for the uninitiated, for the folks who are kind of new to this. See, every kind of task that you have could be kind of broken into this or can be done in this paradigm. So this is a programming paradigm which has been there for a while now. See, to give you some background or historical background, MapReduce model was introduced in a white paper by folks at Google, and you can just have that information if you Google simplified data processing on large clusters using MapReduce. So that white paper is there for everyone. So this paper described a programming model and an implementation for processing and generating large data sets. See, the nature of Google's business was such they had to write crawlers and basically get the right kind of search basically to the end user. So they needed something to kind of they wanted a solution wherein they could get the right kind of search and how they could process such a huge amount of data on the web. Okay. So this programming model provided a way to develop applications to process large data sets in parallel. Okay. And again, without much of the programming challenges usually associated with developing distributed and concurrent application. Okay. So I see a couple of questions. So Chandresh has a question: what is the traditional way reduce map? I did not get your question, Chandresh. So is it related to what you are saying? What is the traditional way as opposed to MapReduce, right? And that's what I'm trying to address right now. Okay. So I'm talking about this use case at Google and how it all started. So when we talk about distributed, okay, sure. So when we talk about distributed frameworks or distributed systems or applications, we are talking about like a cluster architecture where you have a lot of nodes doing work in parallel. So simply put, that is what it is. Okay. So instead of doing the computation on a big server or kind of server doing all the legwork, you divide your computation throughout the cluster or on different nodes. So that gives you a lot of efficiency in terms of throughput, right? Because things are happening in parallel now, as opposed to getting executed. But then there are a lot of challenges. How do you take care of fault tolerance? Or in other words, or simple terms, let's say if you have a cluster of 50 machines or 50 nodes, and a couple of them go down because of whatever reason. So how do you recover those nodes? And then how do you restart your application from where they left off? So these are some of the elements which come into play. So the way Hadoop has been built, or the way it was devised by duck cutting at Yahoo, is that it's basically takes care of all these plumbing services. So you really don't have to bother about anything from an infrastructure perspective within the framework. So how the replication is being done, how replication is a concept for fault tolerance. So any incoming file that you want to process within the Hadoop cluster, you have to, that file is broken into chunk of pieces. So let's say you have a file of 10 GB, it will be kind of placed in different blocks within the cluster on different nodes. Okay, so what you have is all these infra-related services. These are, or the plumbing services, these are taken care by the framework itself. So you don't have to bother about writing code for that, and that's a big thing, right? Because all you have to do is kind of focus on your application and be done with it. So it kind of simplifies that. So traditionally, in the traditional way, it was kind of very difficult to have to address these kind of use cases where you could kind of take advantage of parallelism, or you have applications which could be suitable for distributed framework, because there did not exist any. So taking this cue from Google, there was a lot of traction, and then finally I mentioned duck cutting, who's the he's the one who actually kind of wrote Hadoop, or gave us Hadoop. So taking the cue from that white paper from Google. So what MapReduce Paradigm does is it breaks processing into two basic phases, map phase and a reduced phase. Okay. So there is another question before I move forward from Vinay. So how MapReduce is different from MPI? That's the question. See, MPI has been there again for a long time. See, MPI, for the benefit of everyone, it is message passing interface. Okay, and it supports flexible communication methods, so both asynchronous as well as synchronous. Okay. See, the big difference here is I was going to talk about MapReduce a little more so that the participants get a well-rounded view. But anyway, since you asked this question, let me address it. See, MPI moves the data itself during the communication. So there is the difference. And whereas MapReduce uses the concept of data locality. Okay. So which means the streaming between CPU and disk is possible. And MPI cannot because for the reason I stated, like because it requires will be processed data. That's the term we use. Will be processed data that must fit in the memory in core processing. So you bring computation to data in MapReduce. Okay. So when you create your jar files, basically when your Hadoop job is submitted or you run your Hadoop application, basically a copy of the jar file is placed on the nodes which are running the tasks. Okay, so that is how it is different, Vinay. Okay. So that's the broader level difference. And again, Sahil has a question, which is better for processing, MapReduce or PIG, and when to use what? See, Sahil, there is no kind of one way or the other in terms of saying MapReduce is better or PIG is better. See, PIG offers you a high level of abstraction. So even if see, because skill set is also important. If you don't have people who are very versatile in Java, it's kind of pretty challenging to do MapReduce programming. Okay, and whereas using PIG, and that was the purpose behind kind of developing PIG as an abstraction on top of Hadoop. And see, the development cycle is pretty fast using PIG. But again, there are downsides to it in the sense it takes more time basically to execute. But again, there are improvements going all around in the ecosystem. So even Hive, which is another abstraction on top of Hadoop, it was kind of pretty slow or painfully slow a couple of years ago. But now you have a different kind of optimizers and different kind of the way the MapReduce engine works, or there are other things. There is Thales engine driving Hive, which has made it quite fast as compared to how it was. So these are some of the trade-offs. And see, some of the use cases where you have to do some ETL kind of thing. Okay, you have to extract something and then basically do some transformation. That is what PIG is primarily used for. Okay, you load the data and then transform it. Yeah, right. Yeah, so you can do yeah, joins and all. So you can do transformations. Again, if you have to do joins and all, Hive is more suitable because it is kind of geared for your structured working with structured data. Okay. Yeah, sure, Vicky. That's the objective. So yeah, we'll be able to complete for sure. So and see the applications for Hadoop or see MapReduce is nothing but your batch processing. So wherever you are kind of doing your batch processing, MapReduce is a prime candidate for that. Okay. So your use cases could be anything wherever you have. This one kind of depicts where MapReduce is being used. So you are using it for index and search. You are using it for classification. See, these are the typical areas where you have your business logic or some kind of algorithms. So when we talk about classification, recommendation, these are some of the algorithms which are behind the scenes. So these kind of applications are kind of very apt for MapReduce. So let's talk about recommendation, for example. So recommendation systems are all around us. So even when we go to an e-commerce site, we buy something or we do some transaction, immediately recommendations are kind of offered, or you see, or when you go to Amazon.com or Flipkart or any of those e-commerce sites, the moment you click on something, there is a recommendation for you, and again based on your transactional behavior also, your history. So there is an API called Mahout which runs on top of Hadoop that is used for building your recommendation engine. So that is purely MapReduce based. And for these other types of use cases also, MapReduce is very, very commonly used. Okay. And here is a basic basic explanation of how MapReduce works, and nothing better than an example to kind of understand this. For the folks who are kind of relatively new to this MapReduce paradigm, this should help. Okay, so what happens is this is the overall flow, how basically your MapReduce programming model works. So before we look at this, let me kind of give you the problem statement. So here what we are trying to do is do word count, and it's again, word count is a very canonical example of like typical of hello world that you have in the Java world and all. So your input is basically, it could be anything. So here we are talking about some text. It could be a book, it could be a big file or anything. Okay, so for all practical purposes, it's some text file. Okay, so what we do when your input comes into the Hadoop cluster, you kind of split it into key value pairs. See, in MapReduce, everything is in terms of key value pairs. Okay. And as I said, this MapReduce programming paradigm breaks processing into two basic phases, map phase and a reduce phase. And input and output of each phase are key value pairs. So what happens is here the key is not very important in this case when we are doing the word count application. So we keys are your byte offsets to the file. So we'll kind of largely ignore it for now, and that's what the application also does. So this is the value. So what you have is some way of kind of reading the file and then splitting the lines into words, or basically tokenizing. So folks from the with the Java background, they will be kind of able to relate to it. But in see, in common terms, what I'm saying is you have this file, and what we are doing is we are reading each line or each record, and then parsing the record to extract the words. So let's say the words are these, okay, and that's what happens in the map phase. So you have these words, dear, which is, and what we do is for each word that we extract or each token that we get, we put a count, number 1 against it. So mapper is nothing but your segregation which is happening. So you see, in simple terms, map is your segregation, reduce is your aggregation, as we'll see. So in the map phase, after the split happens within Hadoop, you basically have the map output in the form of a key value pair. Okay, this is the map output. So you have a word and a count of, or basically number 1 against it, and same for all of the words within that file that you're trying to process, and count the number of occurrences. And then there is something within the framework called shuffle and sort. Basically that happens internally, so we don't have to code for it. So all we need to take care of is basically the map and the reduce functionality. And shuffle and sort kind of it does the sorting and gets it in the order for the reducer. And then at the reducer end, what we have is aggregation, as I said. So at the mapper side, you have segregation, and at the reducer side, you have aggregation. So again, all the words and their respective ones, they are kind of summed up. So bear is appearing 2 times. So bear is the count, final count is the what you have is 2. And then same for the other words that are there in the file. And the final result is in the form of a key value pair. As I said, everything input and output is both in the form of key value pairs. So this is a fairly simple representation of what we have or how basically the MapReduce model works. So on the mapper side, you have your segregation, and then on the reducer side, and see it's a little more involved, but we'll not be talking about it at this stage. But this should kind of give you a good understanding of what it is. Okay. See, so let me talk about this talks about the application flow on YARN. But before that, I need to kind of give you some background on YARN. See, earlier, as I said, when Hadoop kind of started, it was supporting only batch processing. So the only type of work you could do was MapReduce, and then other kind of things that you could not do basically. If you wanted to do real time or MPI, which when I mentioned, or any other thing, those were not possible. So and to address that, basically this YARN, or yet another resource negotiator, this was introduced in 2011, and it provides several other advantages as well, apart from running different types of loads or different types of applications. So it includes better scalability, better cluster utilization, and user agility. And also it brings along with it several new services that kind of separated from the earlier MapReduce model. Okay, So obviously we will not be going through the nitty-gritties of that, but that is just to give you some perspective on what this is about. So job execution flow basically is essentially the same when we submit a job on for MapReduce. So once your job is submitted, it's initialized, and then your task assignment, memory assignment, these are the things which kind of the cluster kind of takes care of, or the framework. Okay. So this is in terms of defining in terms of how it happens in YARN. So these are the different components of YARN. It was a little different when it was Hadoop 1.x. So you had a job tracker and a task tracker. But now what you have, it's more of a containerized solution, and the world is going towards that. What you have is a resource manager which does the resource allocation, okay, within the cluster, and you have per application master, and you have the node manager where resources are there. So what you see is container 1.1, 2.1. Basically, these are your resources. When I say resources to run a job or run an application. So these could be your RAM, CPU cores, etc. Okay. So this is from an architectural perspective. So the client submits an application, and then, as I said, resource manager basically allocates a container to start the application manager. So application. So Vicky has a question on application master. See, application master is where the user application resides. Okay. And another question I have is from Bharat. Does node manager manage a single machine or a node? See, this component, yeah, it manages on a single node. Okay. So node manager is basically the one which manages user's job and workflow on a given node. Okay. And together with the resource manager, which is kind of centralized, and this collection of node managers, they create the unified computational infrastructure of the cluster. And the third component, which I just talked about, is the application master, which is the user job lifecycle manager. So application master is where the application user application resides. Okay, so these are the three major components, and they provide a very scalable, flexible, and efficient environment to run virtually any type of large-scale data processing. Yeah, node manager is it's per node manager basically. Yeah. So this is the workflow basically. So resource manager allocates a container to start this application manager, and then application manager basically registers with the resource manager, and then asks for the containers from resource manager, and then application master basically notifies node manager to launch the containers, and that's what we saw here. Yeah, here. So this was depicted here, and this flow is kind of the steps are shown here. Okay, and application code is executed in the container. And, the client basically contacts the resource manager or application master to monitor the application status, and then once it is done, application master unregisters with your resource manager. Okay. Yeah, no problem, Bharat. You're welcome. So Vicky has a question: why application master asks node manager in some other node, not the same node? See, application master is your user job lifecycle manager. Basically, it spans across the job. Okay. And application master is where the user application resides. So that's the reason. and node manager is your per node. Okay. So input splits, I'll move on. Basically, the way the data, once it is there in the Hadoop cluster, how it is split. So that is in terms of HDFS blocks, which are known as input splits, and then basically HDFS blocks are, sorry, your physical blocks, the actual blocks that you have on the data nodes, and the input splits are your logical splits, how your file is split. Okay. And this talks about like if your input splits and HDFS blocks, they are of not the same size. So then basically your split spans across the blocks. That's what it's trying to depict. So the input data is basically sent to the nodes, and then each mapper task basically works on a split of data, the logical split that we have. And mapper jobs always, they produce their output on the local machines or the nodes that there are. And then and because of that, there is some network IO which is involved when you run the reduce job, because the reducer doesn't have this data locality concept. So mappers have. So data locality is you kind of, I talked about bringing computation to data. So within the cluster, the way the files are kind of the blocks of data they are arranged, they are always optimized in terms of data locality. So if your cluster is made up of several racks. Racks are nothing but a group of machines or servers, and those racks kind of comprise a cluster. So there is this concept of data locality. So when you want to, you will have some level of redundancy for fault tolerance. So let's say if you have yes, Jaideep, yeah, split size can vary. Okay, thanks, Vicky. So let's quickly move to the actual thing that we wanted to talk about, or distributed cache. So this is all usual stuff. So in terms of the workflow, basically how it happens when you have the mapper implementation and the reducer, and in between you have this shuffle and sort, and you could have partitioners as well. So we'll kind of move on and see one more thing before we start with our distributed cache example. So we have this different types of input formats. So there are 14 input formats which Hadoop supports. So these are the ones which are listed. And the most common one is basically your text input format, or that's the default input format. Okay, so we'll talk about distributed cache. So Bharat had a question, how does data from a file split as a key value pair? So see, that is done by the record reader basically. There was so there is that's a detailed topic. So surely if you join this course, we'll be talking about it, all these phases in detail, and kind of going through a lot of examples. Okay. So yeah, let's talk about distributed cache. So it's a way, as I said, for kind of sharing your files across the nodes in a Hadoop cluster. Okay. So that could be a very common requirement. So when we write applications using MapReduce, we sometimes are required to share files across all the nodes. Okay, in the cluster. So Hadoop MapReduce framework provides us with this facility, and this is known as distributed cache. And this is to cache files like text files, archives, jars, whatever is needed by the applications. Okay. So again, distributed cache assumes that the files is specified. Again, we have before that, like applications specify the files via URLs, okay, to be cached, and that is through the job configuration. So we'll have a look at the code. And distributed cache assumes that the file is specified via URLs. They are already present on the file system at the file at the path specified by the URL. And again, they should be accessible by every machine within the cluster. So the problem statement that we are going to look at today is like this, and we'll again. Yes, Sahil, you are right. Yeah, that's what it does. Okay. So Sahil was talking about the logic of the word count. Yeah, you got it right. So let me quickly talk about the use case or problem statement that we have. Okay. So I'll just, I have my Hadoop cluster running. So let me go there. So this is the Edureka VM that we have. So in the interest of time, I can so my cluster is up and running. It is Hadoop 2.2 that we have, and let's say we have data related to population that is for different states. Okay, so let me show you the files basically that we have. So here is my data set, and obviously this is a very simple example that I have. So I have two data sets, abc.dat and then whatever distributed cache input. Okay. So the thing what we are trying to accomplish here is we want to kind of have the detailed names for the abbreviated names that we have within this file. So this is some population data that we have, and this is the full form of the different states that we have. Okay, so we can just pass the detailed data to cache. Okay, so this will be basically passed to this, and then we will have it displayed in our output. Okay. So we'll read this file in our MapReduce program where we were depicting the logic to associate the or to get the detailed file information propagated through distributed cache. Okay. So just let me first run it. See, this is where this thing is my this is the directory structure, or this is the HDFS directory. So I'll create basically these files using very simple commands. So let me do this in the interest of time. I have these. So I'm creating in the root folder of HDFS. Okay. So, okay. And this is the detail file. And I'll just walk you through very quickly the code, and then we'll see the output and all. So this is the jar is already there. I've already compiled it and packaged it. So we'll run it. But before that, let's look at the code, what we have. Okay. So every MapReduce program will have similar kind of structure. Okay. And typically will have the very similar structure in terms of text processing if you are doing. So this is basically your mapper, and then what you are doing is kind of reading the file that we have, and you can see this is been struck out because now this when we developed this, this was the API or these were the methods. Now basically it's deprecated. That's why you see it kind of striking line. So you basically read that abc.dat file and split it, and then you kind of tokenize and put it in the hash hash map, and everything is in terms of key value pairs. Okay, and if you're obviously this is for exception handling, and in the mapper implementation what we have is this again it kind of reads from the hash map that we have created and outputs the key value. So basically sets the state and the other data that we had. So it will become very clear when I run it. So, and this is the driver code. So every MapReduce job will have a driver program, which is basically your entry to the main method. And there you set the different configuration parameters for running a job, like in any other platform. So this is specific to Hadoop, where you give the class name and all that. So this is just a map only kind of job. So when I run this, it will basically invoke start the MapReduce engine, and this will take a minute or so to execute. Just copy what the final step is, and we can see the output once this is. So here you have the, and as you can see, map 0%, reduce 0%. This is the MapReduce processing which is happening. Just give it a minute or so, and then it will finish, and we can see the output. So there was no reduce job in this. Basically, all we had was this, and if we do the cat for the output within that folder, it will show up basically. So as you can see, so this detail was kind of passed on across the cluster, and here we are using a single node cluster. So, but the use case is when you have a large cluster and you want to kind of share your files and all across the cluster. This is the mechanism that Hadoop uses. Okay. Yeah, sure, Vicky. So this is your driver program, which has all the configuration stuff. Okay. This is your mapper implementation, which gets the reads the hash map, which essentially you created here. Okay. So it's kind of very straightforward and very simple kind of code. Okay. Yes, with 2.5 it became deprecated, yeah. So you just need to pass the URI basically. That's what we have. So Johar is saying I need some more explanation about the code. So see, Johar, the thing is, this is basically your mapper. Okay, this is the mapper class that you are implementing or defining here, and uh, there is so what we are calling this is my mapper. Basically, it extends the mapper class, which is there in the Hadoop API. Okay, and you define your initial variables and basically initialize the output key, instantiate the output value, and then you basically read this file abc.dat. Okay, and again you are creating a hash map out of that actually, and that hash map is being used in the mapper implementation here. Okay, and this is how basically these so you are getting from that AP map, basically abbreviation or abbreviated map, what we are calling it, and then you are getting it from the hash map INAB, and you are just setting the state and whatever we had in that file, and writing it to the context. Okay, so that is all there is to this. Okay, fine, no problem. So with that, guys, we are done with today's webinar. In case you have any questions, any more questions, let me know. And you can reach out to our sales and support team for any queries regarding the course and anything you may want to know. Looks like we are good. So if there's nothing else, then we'll wind up for today. Course fee and all, I think the sales team, they can answer that. So they'll reach out to you anyway, Abhishek. Okay. You're welcome, Bharat. Yeah. Yeah, Vicky, I'll have to check with support. Yeah, no problem. You can do that. You guys are welcome. All right. Then we'll call it a day. Thanks a lot, guys, for your time, and do appreciate you joining this webinar. Bye-bye.